What's up, guys? My name is Carlton, aka Cisco Tutor, bringing you another exclusive Cisco Lab video. And in this video, we're going to be looking at how to configure network address translation. Be sure to like and subscribe to my channel, guys, as I'm going to be coming out with more videos in the future. If there's any specific topic you would like for me to go over, be sure to leave a comment in the comment section, and I'll make that happen for you guys. So this is the lab that I have set up in GNS3. It's pretty much a simple, basic lab. Right now, I have OSPF configured between routers 2, 3, 4, and 5. So this is OSPF, which means that if I go to router 2 should know about the loopback address that I have configured on router 5. So if I go to router 2, and I do a show IP route OSPF, I know about the loopback of router 5, which means if I were to ping the loopback of router 5, it should be successful, which it is. The problem is I'm not running OSPF on this interface. So if I get my pen, I'm not running OSPF on this interface right here, which means that router 5 does not know how to reach the network that's assigned to this particular interface right here. So if I go to router 2 and I do a show, let me clear my screen. If I do a show IP interface brief, it's this network right here. Router 5 does not know about the 10.10.12.0 network, and we can verify this. If we do a show IP route, notice that he does not have 10.10.12 in his routing table, which means that if I go to router 1, for example, and I try to ping the loopback of router 5, it's going to fail. Now, I could take the easy way out and just configure OSPF on this interface, which means router 2 is going to advertise it into the OSPF domain, but I don't want to do that. So what I want to do is show you how network address translation can solve this problem for us. And we're going to do it 3 different ways. So if I come onto router 1 and I do a show IP interface brief, I have 2 IP addresses. I have the IP address configured on this interface right here, which is 10.10.12.1. I also have an IP address configured on my loopback of 1.1.1.1. What I want to do is I want to do a static mapping on router 2, which is this router, that basically says anytime I see a particular packet and that packet is sourced from 10.10.12.1, I want to translate you to 10.10.23.1. So let's do that. And this, guys, is known as a static mapping, which means that anytime router 2 sees a packet with this source, it gets translated to this IP right here all the time. It's a static entry, and it's only for this IP. So if I go to router 2, I'm going to do a show run section NAT. So I already have some network address translation configuration. I basically said that this particular IP address, or not IP address, this interface, this is my inside. And then this interface right here is my outside. So just to show you that on the command line, if I do a show run interface FA0/0, there's my IP NAT inside on that interface. And if I do show run interface FA1/0, there's my IP NAT outside. So let's configure a static network address translation that anytime router 2 sees this source, it should be translated to this IP. So I'm going to say IP NAT inside source. I'm going to use the keyword static, since this is a static entry. I'm going to say 10.10.12.1, and he should be translated to 10.10.23.1. Now, let me explain to you exactly what this command means. So basically, we're saying that I'm going to do network address translation if I see a packet come on the inside interface, which is this interface right here, so it's coming this way, if the source of that particular packet is 10.10.12.1, let's translate him to 10.10.23.1. Now, this is a static network address translation mapping, meaning only this IP is going to get translated. So if I now, let me clear my screen. If I go to router 1, if I do a ping to 5.5.5.5 and I source this from 10.10.12.1, so the source of this ping echo is 10.10.12.1, notice that it works. Now, the reason it works is, let's look at the packet capture. So if I start my capture, this is between router 1 and router 2. And we're going to start a capture between router 2 and router 3. Let's now start Wireshark. And let's start Wireshark on this interface as well. So right now, I'm going to go back to router 1. I'm going to hit the up arrow. I'm only going to repeat this once. So I'm not going to send 5 echo requests. I'm only going to send 1. So let me stop it right here. And let's go to this one. As a matter of fact, no, let's go to this one. So here right now is my ping echo request. Let me stop this. So if I look at the layer 3 header of this packet, this ping echo, notice that the source of this ping is 10.10.12.1. And the destination is the loopback of router 5, which is what we expect. Now, if we look at the capture between 2 and 3, notice that the source is no longer 10.10.12.1. It got translated to 10.10.23.1. So router 2, as the packet came in, he saw that the source was 10.10.12.1, so he translated it to 10.10.23.1. And if I go to router 5 has a route to the 10.10.23.1. It's an OSPF route. He's using this route. Now, if I go to router 1 and I do it from the loopback is not going to work because I have no entry on router 2 to translate for this particular IP. So notice that it doesn't work because the way it's configured right now, I'm only doing network address translation if the source is 10.10.12.1. Now, I could put in a static entry for router 1's loopback, but in a real world scenario, you're never going to have just 2 IPs that need to be translated. You're going to have a bunch of them. So in a situation like this, instead of doing static entries for all of those IPs, you do better using a pool. So let me translate all of these IPs from a pool of IPs. So let me show you how that works. So I'm going to get rid of this network translation command right here. So let's get rid of that. Now that that's gone, router 1 should no longer have reachability to router 5 if I source it from this 10.10.12.1, which you can see is gone. So let's now do dynamic translation. The way we're going to do this is we're going to say IPNAT, and we have to create a pool. And we're going to name this my pool. Now, the first address that we're going to use in this pool is going to be 10.10.23, and we're just going to say .30. Oops. Now we have to specify what's the last IP address in this pool, which we're going to say is 10.10.23.40. Now we have to give it a prefix length. Let's just say 24. And it says prefix length should be no more than 18. They're on different map. Oh, okay, I see what I did. So I need to change this to 23, not 34. Okay. So now if I exit out and I do a show run section NAT, this is our NAT pool right here. Next, I have to actually configure my network address translation statement. So I'm going to say IP NAT inside, and now I'm going to say source. And now I have to, instead of doing static, I'm going to do list. And we'll come back in a second to create our actual access list. But we're going to say list, and now we have to tell it, well, which access list are we going to use? And the one we're going to create is going to be access list number 1. We now have to specify our pool, which is my pool. So now we have our NAT statement. Let's now create our access list, which is pretty much going to be a standard access list. We're going to say access list 1, permit any. So if we do a show run section NAT or access, this is basically what we're saying when we have this command. Let me get my pen. So we're going to do NAT translation on any packet that comes in on the inside interface, which remember is this interface right here. This is our inside. If the source is from this access list, which is 1, which is right now, all we're doing, we're just saying permit any. So the source can be anything. We're not doing it based on the destination. We're simply doing it based on the source, which can be anything, right? What we're going to do is, if it matches this list, we're going to use the pool, my pool. So again, we're doing translation. If it comes in on the inside, so it's coming this way, if the source based on this access list, which is right here, permit any, so anything can get translated, we're going to use the pool, my pool, which is right here. So we're going to use 10.10.23.30 to 10.10.23.40. So anything between these two ranges right here. So let me clear my screen. If that's the case, I should have reachability to router 5, no matter if the source is from the loopback or if it's from this address right here. So let's verify that. If I do a ping to 5.5.5.5 and I source it from 10.10.12.1, I have reachability. If I source it from 1.1.1.1, and you know what I have to do is, I don't think router 2 has a route back to him, which he doesn't. So I'm just going to configure a static route pointing back to router 1. Okay, that way router 2 will know how to reach it. So now if I hit up arrow and do it again, it works. If I come to router 2 and I do a show IP NAT translation, notice that router 1, the loopback, is being translated to the .31, and notice that the 10.10.12.1 is being translated to the .30. So this one got the first IP address, this one got the second one. And we can verify that by going to our capture. So if I come back to this one, I'm going to close it because GNS3 likes to act crazy from time to time with this packet capture, this Wireshark. I'm going to go here. I'm going to say start Wireshark, and I'm going to come here and I'm going to say start Wireshark. Now, we're going to have to go all the way to the bottom to be able to see this. So let me scroll all the way down, and let me scroll all the way down so I can show you this when I do it. Okay, so I'm going to come back to router 1. I'm only going to do it one time for each one. So I'm going to do repeat 1, and I'm going to do repeat 1. Okay, so notice that each one of them was successful. So let's stop the capture and let's stop the capture. So let's come all the way down here. So this is the one, first one. This is the one coming from the 10.10.12.1. This is the one coming from the 1.1.1.1. So notice that the source is 10.10.12.1 and it's going to the loopback of router 5. And in this ping echo request, the source is 1.1.1.1 and it's going to the loopback of router 5. If we come over and we look at the capture between router 2 and router 3, this is the first one. This was the one coming from the 10.10.12.1. Notice that the source is 10.10.23.30. So he used it from that pool we was talking about. And notice that for the second one, for the loopback of 1.1.1.1, the source is 10.10.23.31. So we're no longer doing just a static mapping between one, but we're now doing a dynamic mapping for everything. Okay. And for example, if I were to go on to router 1 and I created another loopback, let's just say interface loopback 2, and I said IP address 11.11.11.1, okay, I got to go on router 2 and configure a static route so router 2 will know how to get there. Now, if I come back to router 1, if I source it from that new loopback I just created, I should be able to reach router 5, which I can. And then if I go to router 2 and I do a show IP NAT translation, notice that he is getting routed or he's getting natted to the .32. He's getting translated to this. So the way it worked is that the 10.10.12.1, he was the first one to come. He was the very first packet to come in. Since he was the first packet to come in, he got translated. So 10.10.12.1, he got translated to 10.10.23.30. And then 1.1.1.1, since he was the second one, then he got the second IP address, which was 10.10.23.31. And then we created a new loopback of 11.11.11.1. So then he got the third one. He got the .32. Now, this is a good solution, but only if you only have 10, right? So if we look at the range, the only IP addresses we can use from this pool will be this: 10.10.23.30.31.32.33, 34, 35, 36, 37, 38, 39, 40. So this gives us a total of how many addresses? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Which means that I can translate 11 different source IPs into these. But what happens if you have more than 11? That means somebody won't be able to get access to the internet, or I won't be able to translate something from router 1 in order to reach router 5 because I don't have enough addresses in my pool to translate. Now, in a real world scenario, that means you would have to go back to your service provider and get more IPs, which costs a lot of money. So in situations like that, this is where you can use what's known as PAT. And this is how this would work. So the way this works is this. We're still going to say any IP address that comes in on the inside interface, so it's coming this way, It's going to enter this interface, but instead of translating you to a pool, we're simply going to translate everything to the IP address that's on this interface. And the way it works is router 2, even though everybody's going to get translated, he's still going to remember port numbers, right? So imagine if, and this is just for an example, I have 10.10.12.1, and then another laptop has 10.10.12.2. Both of us are trying to go to Google's DNS server, which is 8.8.8.8. The difference between us is that my port number, when I source it, may be 12345 or just 12348. His port number is going to be 12349. So even though both of them are going to get sourced to the same IP or translated to the same IP, the port numbers are different. So when the return traffic comes back, he's not only going to look at the destination IP, but he's also going to look at the port number. So he'll know, okay, I need to translate this particular packet back to 10.10.12.1, this particular packet back to 10.10.12.2. And this is going to save you money because now you don't need to use a whole bunch of IPs. You can just translate everybody to the same IP. This is known as NAT overload, also known as PAT. So let me show you now how that looks. So I'm going to go back to router 2. Let's do a show run section NAT. I'm going to get rid of this NAT rule right here. And first need to go into configuration mode. No. And let's just paste that. Let's say yes. And we're going to get rid of our pool. Now you can do this from a pool as well, or you can simply do it to one IP, which I'm about to show you right now. So we're still going to say IPNet inside source. We're still going to be pulling from access list 1, which is the permit IP any, except now instead of doing it from a pool, we're going to say interface. And we're going to say FA1/0, which is this interface. We're going to say enter. So if we do a show run section NAT, this is basically what it's saying. It's saying any packet that comes in on the inside, which again is this interface, so it's coming this way. If the source, and we're matching it from this access list 1, if this is true, which the access list says permit any, so we're not basing it on the source and the destination, just the source. So if the source is anything, translate it to the IP address that's on interface FA0 or FA1/0, and then this is the command right here that says do pat, so overload. So let's walk through this again. It comes in on the inside interface, which is this interface. The source, and we're pulling it from access list 1, which is permit any, so no matter what the source is, if that's true, translate it to the IP address on interface FA1/0 and do pat. The overload tells it to do pat. So let's see if this works. Let's test it out. Let's clear my screen. And since I stopped it, we're going to have to quit Wireshark. We'll open it back up in a second. So let's see if we have reachability. If I go to router 1, if I ping it and I source it from 10.10.12.1, I have reachability. If I source it from 1.1.1.1, I have reachability. If I source it from 11.11.11.1, I have reachability. Now, let's open back up Wireshark so we can look at the capture. I always believe in looking at the capture because you want to actually see this working. That way you will know that what you did is correct. So now that we have our capture, we're going to have to go all the way to the bottom so we can see this. I'm just going to simply say this. Repeat once, because we only need to see it once. We're going to say repeat once, and we're going to say repeat once. So we're going to stop it, and we're going to go to the one between router 1 and router 2, and we're going to say stop. Now, if we come all the way down to the bottom, we have 3 echo requests coming from router 1. Okay, we have 3 of them. The first one has a source of 10.10.12.1. And notice that they all go to router 5. The second one has a source of 1.1.1.1. The third one has a source of 11.11.11.1. So 3 different ping requests coming from router 1 with different sources going to router 5. If we now look at the capture between 2 and 3, and okay, so, okay, I got to go to the bottom. That's right. That was at the top because I was looking at like, that don't look right. Okay, so let's go all the way to the bottom so we can look at the ones we actually just did. All right, so check this out. Notice that each ping request, right, has a source IP address of the interface configured on router 2. They all have this 10.10.23.2 as the source. So if I come to router 2 and I do a show IP interface brief, this is the IP address that they're getting NATed to. All of them are getting NATed to this IP. So this is, guys, how PAT works. All of them are getting NATed to this IP. And if we come to router 2 and we do a show IP NAT translation, and let me see. Let me see if I can see it. Let's do this again. Let's see, router. Let's do that one. Let's do that one, and let's do that one. Is it going to show it to me? Okay. So notice this is the actual port right here, right? So notice that. Let me get my marker. Notice that the 1.1.1.1 got translated to this IP. They all get translated to this IP right here. It's just that this number right here, the port number, is totally different. This is how he's able to keep track of which ones should be translated back. So if I take this out, let me go back to my screen here. Let me clear this. So even though you have traffic coming from router 1 going this way, coming in on router 2, and they're all destined to 5.5.5.5, even though they all have different source IPs, and even though as it's leaving router 2, they're all being translated to the IP on this interface, router 2 is able to keep track of all that information so that as the traffic comes back, it's going to get translated to the correct address. And we can see that because if we look at router 2, well, let's look at this one. Notice the request or the reply. All of them are destined to the same IP address. So the reply coming back from router 5, they're all destined to 10.10.23.2. But if we now look at the capture between router 1 and router 2, notice if we look at the destination of the reply, router 2 is able to translate all of these replies back to the correct IP. So guys, what did we look at in this video right here when we did our network translation. Well, we looked at how we can do a static translation. So what we did was on router 2, we configured a static NAT that said anything that's sourced from 10.10.12.1, translate him to 10.10.23.1. And when we did that, we saw that if I was to ping router 5 and I sourced it from the IP of this interface, I was able to reach router 5's loopback. But if I was to source it from the loopback, I wasn't able to get there because I was only doing translation for this IP address. The second thing we did was we did a dynamic mapping. So we did it from a pool. So what we did was we basically told router 2 that if any packet came in on this interface, I really don't care what the source of the packet is. So we had a standard access list that said permit any. So I don't care what the source is. If it comes in on this interface, we're going to translate it from a pool. And the pool was 10.10.23.30. And the final, and it was basically between 30 and 40. So 10.10.23.40. I'm going to translate using this pool. So when it came in from this IP, we saw 10.10.12.1 get translated to the .30. We saw 1.1.1.1 get translated to the .31. And then we just created a loopback to test, and we saw him get translated to the .32. And no matter what IP I sourced it from, all of them were able to get translated, and all of them were able to reach router 5. So that was doing it from a pool of IP addresses. And then we did it to where it was still coming in on this interface. I still had my ACL saying, I don't care what the source is, because we use a standard access list. We didn't match it on a destination. So we didn't use an extended ACL. So I don't care what the source is. And instead of natting you to a pool, everything got translated to the IP address on this interface, which was 10.10.23.2. So it didn't matter if it was coming from 10.10.12.1, you still got translated to 10.10.23.2. Didn't matter if it was coming from 1.1.1.1, you got translated to the same address. Just like it didn't matter if it was coming from 11.11.11.1, you still got translated to the same address. And that, guys, is how network address translation works. Hope you guys enjoyed this video. Be sure to like and subscribe. And again, guys, if there's anything you would like for me to discuss, leave it in the comment section, guys, and I'll definitely make that video for you guys. Thanks for watching, guys.